According to Wikipedia, the Internet of Things, or IoT, is the network of physical devices, vehicles, and other items embedded with electronics, software, sensors, actuators, and network connectivity, which enable these objects to collect and exchange data. This is a fairly broad definition and can cover devices ranging from very small microcontrollers that are barely able to communicate with the outside world to systems that could have been considered workstations just a few years ago, with gigabytes of RAM, graphical user interfaces, and operating systems such as Linux. RFC 7228 attempts to define some terminology to allow these devices to be discussed in a way that everyone involved can agree on what class of device is being discussed. The RFC uses the term constrained node, which it defines as a node where some of the characteristics that are otherwise pretty much taken for granted for Internet nodes at the time of writing are not attainable, often due to cost constraints and/or physical constraints on characteristics such as size, weight, and available power and energy. The tight limits on power, memory, and processing resources lead to hard upper bounds on state, code space, and processing cycles, making optimization of energy and network bandwidth usage a dominating consideration in all design requirements. Also, some Layer 2 services such as full connectivity and broadcast multicast may be lacking. Although the RFC focuses primarily on the network services available to IoT nodes, much of what it discusses applies to other topics, including resources available to implement device security. The RFC defines a small set of succinct terms to describe a few general classes of devices that it refers to as classes 0 through 2. Class 0 describes devices with much less than 10 kilobytes of RAM and much less than 100 kilobytes of flash. These devices are the most limited and are unlikely to support protocols such as TCP/IP. From a security perspective, they will generally be running a small amount of fixed code that may not be easily upgraded. Class 1 is used for nodes with around 10 kilobytes of RAM and around 100 kilobytes of flash. These devices are still not able to use higher level protocols such as HTTP or TLS. However, they are generally able to use constrained device protocols such as CoAP. From a security point of view, they will likely still be running a single pre-built piece of code, although this will probably be upgradable over the network. Class 2 is for devices having approximately 50 kilobytes of RAM and around 250 kilobytes of flash. This is large enough to support higher-level protocols such as HTTP and TLS. Significant from a security perspective, these devices may also have enough room to support externally loaded applications, such as scripting with a language like MicroPython. At this size, it becomes important that the device be able to store some secrets, such as private keys or shared secrets, to allow communication to be secure. But it is still important to protect these secrets from parts of the system that do not need to know this information. This class 2, however, is still small enough that more general mechanisms, such as memory management, user space isolation, and so on, aren't practical. This is the level where Light will be focusing our efforts on, and is a good match for the capabilities provided by Zephyr. There are many devices that are larger than this configuration, although they tend to be considered more general-purpose computers that happen to be used in an embedded or IoT environment. Something like the Raspberry Pi family would fall in this environment. There will also likely be devices that fall somewhere between the RFC's Class 2 and these general-purpose devices. It may be useful in the future to define other classes of devices to cover these specific use cases.